welcome all of you to yet another video dedicated to physics. Now you all must be wondering that why have I posted this picture of colorful crystals? Well, don't worry, we are not going to discuss about astrology. In fact, I just want you guys to have a look at these crystals, how beautiful they are, the color they exhibit, the shape, the density, composition, everything would be different. What is that which differentiate them from each other? And indeed, they are so mesmerizing to watch. And many people, they ask the astrologers for some stones to wear, and it is a belief that these stones actually lead to some fortune. But I won't validate this thing until I observe it myself, or if there is any scientific evidence behind that. But scientifically, yes, all these crystals, even if the stones people wear like turquoise or opal or sapphire, emerald, ruby, they are different in some sense. Their composition is different, their shape, color, everything is different, and each material exhibit different properties. But these are observable properties. Now you can see all these crystals, they appear to be different. They are exhibiting different shapes and colors, and if you can touch them, maybe the surface would be different. Some are quite smooth, some have rough texture, and in fact some would be lighter, some would be heavier. So they exhibit properties which we can observe, and if different material have different properties, then they would be performing some different functions. So when astrologers actually suggest you to wear some stone, then I guess there might be some sort of scientific basis behind that. Well, yes, today we are going to discuss about crystals. In general, we are going to start a new topic, which is crystal structure. An important topic. This is part of condensed matter physics paper in BSc 5th semester course. So crystal structure is the chapter, and today we will discuss about crystals in general. As I mentioned that these crystals, they are just totally different from one another. How can we say that they are different? Well, we can observe them. We can tell that their color is different, their shape is different, their texture is different, and maybe their weight would be different. And if we go for some tests like elemental composition, if we go for checking the elemental composition, then they would be of different elements. So they would be compound of some different proportion of elements. That means we can actually tell the difference between them. And all these observable properties which we can directly observe, they are called macroscopic properties. Means we don't need to go for any finer or quite detailed piece of instrument to actually observe the difference. There are some things which look alike but they are entirely different, and there are some things which look different and they are different. So it's really easy to differentiate between objects which actually look different from one another. And that can be done simply on the basis of observation. So all these observable properties, we call them macroscopic properties. These are the observable features, and we also call them macroscopic properties, which can be directly observed or measured. So these properties are like color, shape, texture, etc. And since this is the part of condensed matter physics, the main foundation of condensed matter physics is studying all those objects which we see in daily life, which come across in our routine. And all the properties which are macroscopic, which are observable, if we have to study those properties, then all that study would come under condensed matter physics. Okay, so it deals with macroscopic properties of matter. So matter has different properties, electrical, optical, and so on. But in general, when we talk of macroscopic properties of matter, when we talk about its shape, color, composition, we are actually talking about the material of which the matter is made of. I hope you can understand this statement. Well, in that, all this comes under condensed matter physics. Also, anything which is in condensed form. What is the meaning of condensed? Anything which is quite dense, we call it condensed. Okay, so solid comes under this category. It is a condensed matter. Also, whenever we say that there is phase change from one type of matter into another, then also we call it condensed matter. Suppose a gas, it converts into liquid. Also, we know that there is a term called condensation. When molecules start coming closer to each other, the intermolecular forces of attraction increases and the intermolecular spaces decreases. So the space decreases and the force between molecules increases. In that case, what happened? Gas converts into liquid. So that process is called condensation, and then we can say that yes, liquid is a condensed matter. Gas has condensed into liquid. Similarly, we know that even liquid can also condense into solid. If we freeze the liquid, what will happen? All the molecules would come even closer to each other and they will just join together. So more of a shape, a defined shape would start appearing. Then also we can say that yes, solid is a condensed matter. Liquid condenses into solid, so solid is condensed matter. So in this way, we have got two examples. We have two examples of condensed matter. One is solid and another one is liquid. So the main thing to remember is that condensed means something which is really dense. So all those condensed phases which appear whenever density of the system is really large, then the matter, whatever matter is it, we say that it is condensed matter. And we have two examples. One is liquid, which is condensed form of gas, and another one is solid, which is condensed form of liquid. So how easy it is to understand. We are not saying anything which is totally solid in state. We haven't said so. Condensed means when density is really large, and it can be large in case of liquid as well. We know in case of solids, all the atoms, they are tightly packed. So obviously the composition is rigid, the shape is rigid, and definitely solid cannot change its shape on its own. It's fixed in shape. But for liquid, we say that it has no fixed shape, but still it has definite volume. It takes the shape of the container in which it is poured. This is just the basic knowledge that we have for liquid. But still, density of liquid is greater. And if we talk of very dense liquids, then all those liquids come under the category of condensed matter, specifically dense liquids. So anything which is associated with high density, you would count it as condensed matter. Thus, high density or system with extremely high density is the main point that you need to remember. So, if you are seeing here the crystals, definitely they are condensed matter because it is possible that they might be formed from some liquid state or some molten state. In fact, the liquid that we consider under condensed matter category, they are not totally flowy as liquid is, like water, it's really flowy. We actually talk of those materials or those liquids which are quite dense, dense like lava. Here you can see all the examples. We have here condensed milk. See, the name itself says condensed milk, so it's the solidified milk. If you just keep on heating milk. So ultimately it solidifies. The liquid content, it just vaporizes, keep on vaporizing, and what is left is basically the solidified form. So it's, you can see it's still liquid also, but it's not that flowy as normal liquid is. It's kind of solidified. Then these bottles, you know how glass is formed. It's kind of a molten lava sort of stuff. It's molten at high temperatures, and then what happens when temperature is cooled down, then they just take some shape and they solidify. Then the lava itself is a form of condensed matter. Then this scrumptious chocolava cake, you can actually see that the lava, the chocolate, the melted chocolate is example of condensed matter. Then when you have a candle and the wax melting, that is also a form of condensed matter. So always remember liquid and solid. Okay, so we have liquids and solids which we collectively count under condensed matter. Okay, because liquid is condensed state of gas and solid is condensed form of liquid. All right, so I hope that this idea of condensed matter is clear. You can also say anything which is semi-solid, half solid, half liquid, that would also come under condensed matter. There are many examples in higher classes, and in fact in some future topics you would study about superfluids, you would study about Bose-Einstein condensate. So all these refer to something which is not completely liquid and also not completely solid. So something in between. So it's flowy, but it is kind of dense liquid. Then superconducting phase exhibited by conduction electrons. That phase is also considered to be condensed matter phase, because it's always said that when we talk of electrons, electrons which are there in a superconductor or electrons which form Bose-Einstein condensate, they all behave like a fluid. When they move, they don't move like a single solid particle is moving. No, they move, they kind of flow. That is where this condensed matter has originated. Because when you actually observe the motion of electrons, the way they move, we don't say move, we say they flow, because they flow just like a fluid. And that's why we try to understand the behavior of those electrons in terms of liquids, in terms of fluids. We know what are solid, we know what are liquid, we know what's fluid. Usually the word fluid is referred to something which is liquid but quite dense. And same is the situation with electrons. The electrons which flow in superconductors, they kind of flow like a fluid. And to understand their behavior, we compare them with fluid. We observe the behavior of a fluid and then we try to compare it with the flow of electrons. Thus, today condensed matter is one of the largest fields of physics, and it grew out of solid state physics. So here you can see all the atoms. It's just a replica showing how atoms are packed in a solid. So before, people just used to talk of solid. So there was solid state physics because solid is a state of matter. But then this condensed matter came into picture. Something which is neither solid nor liquid, a semi-solid state. Okay. So to study those materials, this condensed matter physics came into picture and actually grew out of solid state physics. And the reason why we call it condensed matter physics is because many of the concepts and techniques that we study and that have been developed for studying solids, they can be applied to fluid as well. Today we say that we have these conduction electrons in an electrical conductor which form a type of quantum fluid. We have conduction electrons in an electrical conductor and it forms a type of quantum fluid. You will study it because now we say that the behavior of electrons is something which can only be explained by quantum mechanics. So electron is a quantum particle and the way they flow, the way they move in the conductor, it's the motion is more like that of a fluid. Sometimes we also say electron gas, or sometimes we say that they form a type of quantum fluid and the properties are exactly similar to that of normal fluids. Okay, so that's the reason. And in fact, when you study superconductivity, you will see that their electrons condense into new fluid phase where they can flow without dissipation of energy, and that is almost similar to a superfluid phase found in helium-3 at low temperature. So the kind of superfluid phase which we experience in helium-3 at low temperature, where it actually uh, exhibits liquid behavior, the same, almost same behavior is shown by electrons in superconductor. And that's the reason electrons, which we say they are particles, they are quantum particles, they are behaving like fluid. So to understand how are they moving, how are they flowing and their behavior, it is very easy for us. If we can understand the way a fluid moves, we can easily understand the way electron will move. Alright, so this is all about just the introduction, that how does this condensed matter physics applied everywhere now. We have amorphous solids, we have non-crystalline solid, glasses, we have liquids, then polymers, then we have crystalline solids. All these come under condensed matter because normally phase change is associated with these. So I would also say here that a phase change is associated with these materials. So whatever comes under condensed matter physics, it would have some sort of association with phase change. Whenever you will see change of phase from one state to another, condensed matter will help you in understanding all the concepts and phenomena going on. Okay, so coming back to crystals, as you can see, a crystal is a solid. It's clearly shown in the pic that they look like solid, and solid is made up of molecules, atoms and ions, and they would be arranged in some pattern. So usually fluid substances, they form crystals. As you can see here, all these crystals, they are showing pattern of a liquid, of some fluid. See, you can, in this light purple crystal, you can see these layers. It's just that you have enclosed some sort of fluid in a container. It looks like this. All these crystals, they are depicting solidified fluid. You can actually see it. It's visible. See, all these are looking like some fluids which have been logged somewhere, logged in some solid region. And all the fluid substances, they form crystals when they undergo a process of solidification. So whenever those situations arise that they undergo phase change and they solidify, then crystals are formed. So this particular video was just about giving general idea about what is condensed matter physics and what are crystals basically. and why we are studying about crystals in condensed matter physics. Crystals, they are solid, we know that, but why are we studying them in condensed matter physics? Now you can understand that basically all these crystals, they are formed from fluids. When fluid substances solidify, they form crystals. And that fluidity, that behavior can be seen on their appearance. See, the appearance of every crystal more or less looks like a liquid which is locked in some closed entity. Okay, so that's all for today, and now in future videos we'll discuss this topic of crystal structure in a physics manner. We'll talk about different scientific terms. There would be some formulae, some derivation, some diagrams. So we'll do all that. Till then, keep learning physics and keep watching my videos, keep subscribing and liking. Thank you.